Hello and welcome. This is a math affair, and today we're going to be talking about surds. We are going to introduce surds. What on planet math are surds? All right, so I defined surds right here as a root whose decimal is irrational. If I take a root and the decimal form is irrational, then I have a surd. What is irrational? Let's take, for instance, the square root of 2. The decimal form of square root of 2 is 1.414213, as we can see. And this decimal is not only large, it actually goes to infinity. And if you observe the decimal part, there are no repetition of digits. There's no pattern whatsoever. It just continues to change the digits, and as we go to infinity. So it does not stop and it does not repeat. This is what we call an irrational number. So any root whose decimal is irrational or whose equivalent form is irrational is a surd. So keep in mind, it's not every root which is a surd. Only those roots whose decimal forms are irrational are surds. To help you further understand, I have a list of roots which I want us to look at. And this mini exercise will be more effective if you have a calculator in your hands. Starting up with the square root of 4, if I calculate the square root of 4, this would give me just a whole number 2. Now, the equivalent for square root of 4, which is 2, is not irrational. Actually, 2 is rational because we can write 2 as 2 over 1. But on the other hand, if you would take the square root of 8 and cross-check this on your calculator, you are going to definitely end up with 2.82842, etc., etc. You can cross-check that. You're definitely going to end up with a surd. Root 8 is a surd. Square root of 4 is not a surd. Similarly, if you would calculate the square root of 7 is approximately 2.645. Again, observe the decimal part. You would notice there's no pattern to it, no repetition. And on a larger screen, this does not terminate. It doesn't stop. So this is definitely a surd. Similarly, you want to take a look at the square root of 20, which is approximately 4.472, etc., etc. Again, this is a surd for sure. This is a surd. What I want you to observe as you are doing these calculations is the decimal part of these numbers, of these calculations, of these roots. If they do not terminate, there are no repetitions, there's no pattern to the decimal digits, definitely you have a surd. Now, cube root of 10 is also a surd. You can cross-check this on your calculator. It's definitely a surd, but I put up this example just to let you know that we are not only dealing with square roots. This definition of surds is not only for square roots. Any root, whether it's the square root, cube root, fourth root, fifth root, any root whose decimal is irrational is a surd. So cube root of 10, I'm sure you can verify that on your calculator, or you've done that already, is definitely a surd. But take a look at the square root of 2.25 finally. This is equivalent to a 1.5. Now, 1.5 is a decimal which terminates, it stops, and it actually stops after one digit. And we can definitely convert this to a fraction, which is 3 over 2, also known as 1.5. So the square root of 2.25, therefore, is not a surd because the decimal is not irrational. So this is the idea of surds, roots, with very bad decimals. I'll put it in quotes, right? Bad in quotes, right? These decimals which are infinitely, large and they don't terminate, and there's no pattern to them. And more worse, what is worse, what is the worst case scenario in this situation is the fact that we cannot convert them to fractions, which makes calculations, challenging, right, with roots, particularly when they're in their decimal form. So what we want to do is to keep these roots in their exact form. We keep the roots in their exact form. So if I go back up, I would say this is the exact form of root 2. I would say this is the surd or the exact form. So when I write it as a root this way, this is exact form. Well, what I have on the other side is the decimal form. This is the decimal form. So what we want to do is to keep roots in the exact form and be able to manipulate them, multiply, divide, subtract, carry out basic operations. Now, to help us work with surds, we have important properties to look at. You can call these rules, laws, properties. Yeah, these are rules or laws of surds. To begin with, if I have the square root of a multiplied by the square root of a, this just returns a. Meaning when a surd multiplies by itself twice, this is just a. The roots would cancel, and I just remain with a. Well, we can understand this because multiplying a number by itself twice is the same thing as squaring. So if I take the square root of a and I square, the square root and the square are reverse operations. They are inverse operations. They're going to cancel each other out, and all we have at the end of the day is just an a. So self-repeated multiplication twice of any surd just returns the number. The second law is the law of multiplication. If I have the square root of a multiplied by the square root of b, we can rewrite this in this format as a single root, and I multiply the numbers. So I take my arguments a and b and I multiply them and place this under a single root. Now, we can work either way, depending on what we are trying to achieve in a question. Maybe you are trying to simplify and you want to separate, you can separate. So if you start up with the square root of a times b under the same root, you can split and separate and write them separately as single root of root a multiplied by root b. But if you're trying to put them together, then you can also go this way. So keep in mind, you can go either way. Then finally, we have the law of division or the rule of division. If I have the square root of a divided by the square root of b, I can also rewrite this as the single square root of the quotient of a and b. So we can put them together, your numerator and your denominator, under the same root sign, or we can separate them and rewrite them as just the square root of the numerator divided by the square root of the denominator. All these forms are equivalent. We are saying these are equivalent. So these three rules these are the primary things you need to know. These are the primary things you need to keep in mind as we are going to be working with surds, from one operation to another, one lesson on surds to the other. Keep these rules in mind. Watch out for the next video on surds. We're going to be simplifying, adding, subtracting, multiplying, dividing surds.